Algebra 2. This is a recording for the people who are gone, whoever wants to watch this. All right, so in section 3.5, it says solving quadratic equations. We were doing that before. We were solving quadratic equations, right? Yeah. But this is just using a different method. Okay, so a quadratic equation is going to, when you graph it, just look like a parabola. Maybe one of those, something like that, right? And when we're finding the solution, what are we trying to find?
The zeros.
The zeros, like these places. This is what we are looking for. Whoop. We are looking for this guy, we're looking for this guy, and this guy, and this guy. That's what we're trying to find. Okay? Now, first and foremost, we want to factor. Factor if possible. Shh. We want to factor if possible. Okay, there's 4 methods of factoring. We talked about those in the last section. What are the 4 methods? What is a way to factor? What are your ways of factoring? What? Greatest common factor is one of them. Okay. She's got us started. What else? Complex trinomial. What else? Difference of squares. Simple trinomial. Those are all ways of factoring. Right?
Really delayed.
I know it is really delayed. Sorry. It's because I'm videotaping. So all 4 of those are ways of factoring. Now, not everything you are able to factor. So if you can't factor, if it absolutely none of those methods will work, if you can't factor, do this, which is called completing the square. If you can't factor, you will always be able to complete the square. Okay? And that's what this looks like. If you can't factor, you do this. This is your kind of last resort.
Okay, I have a question.
Yes, ma'am.
So the first way you showed us how to solve equations, can we do that?
What do you mean?
Do we have to do this?
What do you mean?
Like, how are we solving it?
By factoring?
Yeah. No.
Some of them you will not be able to factor. So you will have to do
like,
it.
Yeah, like we did in previous lessons, like before this. Can we do it like that instead of this?
Like by factoring? By breaking it down in parentheses?
By the, like...
Oh, by doing the vertex and
Yeah.
graphing it? Yes, that's another way of doing it. Yes.
But
By
do we
finding...
have to do this?
Yes, you have to do this. You'll like this. This is not too bad. Okay? So yes, you're right. You can graph and find those zeros that way, but I don't want to graph all the time, right? I just want to find them. So this is the completing the square. Now, in example 1 and example 2, you're only doing the second half of completing the square. Okay? So they're going to really baby step you into this, and they're just going to do how you do the second half of completing the square. We're not doing the whole thing right yet. We're going to baby step into this, okay? Now, when you're completing the square, a lot of times you will when I would see this problem and I was trying to factor, most of the time I would want to bump this 36 to the other side. But for completing the square, he stays. You don't move him to the other side. And you don't set him equal to 0. That guy's going to stay there. He's going to stay right there where he is, okay? Now, when you are completing the square, you are going to kind of factor. And I'm looking at this guy right here. X squared plus 6x plus 9. Okay? And we're going to factor this guy down. And I'm going to look at him and I'm going to say, what can I, because this is a simple trinomial, what can I multiply to get 9, but when I add them, give me 6? 3 and 3. 3 and 3, right? So this would be like x plus 3 and x plus 3. 3 times 3 is 9. 3 plus 3 is 6. Yeah? Okay, but then that, if you have x plus 3 times x plus 3, what's another way of writing that?
X plus 3 squared.
X plus 3 squared, right? And that is equal to what?
36.
36 is on the other side. We're almost there. Okay, so x plus 3 squared, because it's x plus 3 times x plus 3. Okay, are you writing this down? Don't lie to me, you are not. Write it down. Okay, now, how do you get the x by itself? How do you get rid of this square? You do what? I think somebody said it. You don't make another one. What's the opposite of square?
You square root.
You square root. We're going to take the square root. The opposite of square is square root. So to get that to go away, we just take the square root, right? Okay, so x plus 3 squared, if I take the square root of that, x plus 3 just falls out of it, right? So this stuff cancels out, okay? And then, what's the square root of 36?
6.
You're kind of right. You're kind of right,
9.
okay?
6 squared.
Nope, okay? It is true that 6 times 6 is 36, right?
Yes.
But, what if I take negative 6 times negative 6?
That's still 30.
That's still 36. So, we need positive 6 or negative 6, and that's how we write it, plus and minus 6, okay? Now, listen to this. This is very important. I'm going to put a little star over here. Going forward, anytime we insert a square root, always use plus and minus. Anytime we put the square root in there, it's always going to be plus and minus. So it's not just positive 6, it's negative 6 also. Going forward, that will always be the case. Always use plus and minus. Excuse me. And then if I want to solve for x, I'm going to get x by itself.
So you gotta
You have to
subtract
subtract it.
Subtract the 3. So x is equal to, this would be positive 6 minus 3, but then it's also negative 6 minus 3. So if it's positive 6 minus 3, what's the answer? 3. If it's negative 6 minus 3, it's negative 9. So the answers are 3 and negative 9. You betcha. 3 and negative 9. There they are.
Hey, Lily. So after you squared it, you got it out of the square root.
Mm-hmm.
Then you have to subtract 3 over and you just do both of them.
Yep, do both positive 6, negative 6. Yep. Now, what does the answer 3 and negative 9 do for me? What did we just find? The zeros, excuse me. So, what we just have found is that negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is where he crosses, and 3 is where he crosses. So I'm going to have a parabola that looks something like that, right? That's what I've just found, but I've done it not by factoring, by completing the step, right? Okay? All right, next one. It's a really wide one. Yeah. Okay, so same thing here. This 27 is going to stay on that side, but the x squared minus 10x plus 25, I need to factor him down. So he's going to be 2 pieces. What can you multiply to get 25, but when you add them, give you negative 10?
Oh, wait. Negative 5 and negative 5.
Negative 5 and negative 5. When you are doing this process, you want whatever you have to be the same, right? It's got to be the same 2 numbers. X minus 5, x minus 5. Okay? Multiplied together gives me 25, but adding those will give me negative 10. Okay, but another way of writing x minus 5 times x minus 5 is
X minus 5 squared.
x minus 5 squared, you bet, equals
25 squared.
what?
27 squared.
27. Okay, and then, hold on. It's not 27 squared. We're just reducing the left side. The left side, this guy breaks down into x minus 5 times x minus 5 is x minus 5 squared. Now, to get rid of the square, we have to take the square root.
That's what I meant. Was
Yep. Okay?
Yeah.
So, when we take the square root of x minus 5 squared, x minus 5 pops out.
X minus 5.
And the square root of 27, does that come out nicely?
No.
No, so we're going to leave it as the square root of 27, but what?
We could. Are you supposed to do like?
We can probably break it down, but we're not going to for now.
Are we going to put plus and minus?
Yes, that's what we need. Ashton's got it. We have plus and minus. We put the square root in there. So it's still going to be plus and minus. Always. We put the square root in. Okay, now what?
Then you have to solve it. You have to subtract 5 over.
Add the 5 over to the other side. Now, can you add 5 to 27?
No.
No, because the 27 is on the inside of the square root, right? So here's how you're going to write your answer. X equals 5. I always put that number first, and I put my square root last. This is what he will look like. 5 plus and minus the square root of 27. Okay, now, we're going to leave our answer like that, but just to kind of show you what happens there, how many answers are represented in 5 plus and minus the square root of 27? 2, right? This would be like 5 plus the square root of 27. and 5 minus the square root of 27. Okay? If you type those into your calculator, you will get the numbers 10.2 and negative 0.2. Okay? If you type in 5 plus the square root of 27, 5 minus the square root of 27, you will get those as answers. 10 point, like, it's 10 by like 1.9 or something, 1.9, okay? And negative 0.2. So we still are getting 2 answers, but they're really ugly decimals, right? So you're going to write your answers 5 plus and minus square root of 27.
So we don't have to do the square root.
You do not have to actually solve it out, but I want you to think about that and know that this actually means 2 numbers, right? If we were to solve them out, those would be the decimals, yeah? Okay? So that's where he would cross at. Does that make sense? If it doesn't come out nicely, just leave it like this. If it does, like the square root of 36 did up here, we're going to solve them out, okay? All right, so let's get on to this next one. Example 3 is really short. It says find the value of c that makes this a perfect square. So we have x squared plus 16x plus 6, or plus c. So what I want to have happen is I want x squared plus 16x plus c to break down into something squared, right? Okay? And it will look like this, okay? So I'm thinking about this in terms of like what we did up above. What can I multiply to get this number, which is c, but when I add them, give me 16, right? So what can I multiply by itself to get this number, but when I add it to itself gives me 16?
Not 4.
I want something, no, it has to be the same number.
No.
I want a number that basically I can add to itself to get 16.
8.
8 and 8, right?
8. So that c would be 6.
So x plus 8, yes. X plus 8, which would make that whole thing come down as x plus 8 squared, right? They want this part, but then they're saying, okay, what does c have to be? Like, what would this number be right here?
64.
That guy would be 64 because 8 plus 8 gives you 16, but 8 times 8 gives you 64. Does that make sense?
Yes.
Okay, so let's come up with a formula, kind of. How do you get that number 8? Like, if we had to put a formula to it, how did we solve for that number 8? Like, how did you know that that was 8?
Because you just have to find something that would add.
So it has
Right,
to
so what did you kind of do?
be no.
Mm-hmm.
Yeah.
The b value was 16, so we took 16 and we did what? Divided it by 2, right? Okay, that's like you're saying your b divided by 2. That will give you what 8 is,
So
right? That's 8.
So yeah, b divided by 2.
b divided by 2 is that. Now, how do you find what c is?
Then it would be that square.
Yeah,
Square.
b divided by 2, if you take that and you square it, then we'll give you what c is, right? If you take that number, this number, after you divide it in half, and you square it, we'll give you this number, right? Okay?
Yeah.
So they want 2 things. They want what c is,
Which is 64.
which is 64, and then they want you to write it like this. X plus 8 squared, okay? All right, so that's the front half. This is like the first half.
Wait, there's number 4.
First half, just wait, this is the first half of completing the square. S-Q-U-A-R-E, there we go. That's the first half of completing the square. Now we're going to put the 2 together. Okay, we're going to put the 2 pieces together. All right, so example 4, we're going to do both of those at the same time. We're going to combine them, all right? And it's not going to be terrible, right? X squared plus 10x minus 11 equals 0. The first thing that you want to do is get the x's on one side. I'll write this over here. Get the x's on one side and numbers on the other. So get the x's on one side and the numbers on the other. So what needs to be moved?
The 11.
The 11. This is the only time you ever kick that 11 to the other side or that number to the other side. Usually you leave it equal to 0. But we're going to kick the 11 over to the other side.
You have to add 11.
So we would have to add 11. So I'm going to leave x squared plus 10x. And I'm going to leave a space because we're going to fill that space in here in just a second. Because this is going to be like your c value. Okay? Equals 11. Okay? And I'm going to put plus blank here. And I'm going to put plus blank here. Okay? Completing the square is completing the blank. I tell my all my upper level kids that, like my trig kids, completing the square, completing the blank. That's how they remember that. Completing the blank, completing the blank. Okay. So just like what we did up here, x squared plus 16x plus c, we have to figure out what c has to be, right? So I want to be able to write x squared plus 10x plus whatever this number is, like this, and eventually like that. Okay? So I need a number that when I multiply it by itself gives me this, but when I add it to itself gives me 10.